All right, you guys, our last section of topic 3 is actually section 7.1, and it's not in your workbook because 7.1 talks about dilations, which is when we change the size of our shape. We either get bigger or we get smaller. So you can just take these notes on any type of sheet of paper, and let's write down some main ideas of dilations. A dilation is a transformation that we have a center of dilation and we have a scale factor, and we use n to represent that scale factor. And that scale factor represents how the shape changes. So we have this little diagram here, and some big takeaways is that each length in the image is n times the corresponding length in the pre-image, aka we multiply by that scale factor to either enlarge or reduce that image. If the scale factor is greater than 1, it's an enlargement, the shape gets bigger. If the scale factor is less than 1, the shape is a reduction, it gets smaller. So the scale factor could be some type of fraction like 1/2, and it gets smaller by 1/2. Big things to know is that every angle is congruent. And if we are on a coordinate plane, this notation, d sub n, describes a dilation at the origin as the center of whatever n scale factor is. So let's do some examples. This example is going to be us finding the scale factor. It gives us quadrilateral JKLM, and it tells us that J prime, K prime, L prime, and M prime is a dilation of that original shape, and we want to find the scale factor. The scale factor is just the ratio of the side lengths from the image to the corresponding side length of the pre-image. So in this example, we see that we've got this orange shape. That is the image. And remember, the image is your transformed shape, so after the movement. So you could note that as like your new shape. And the pre-image is your starting point, that original or old, however you want to think about it, shape. So the two side lengths they give us is side length KL and K prime L prime, and those are corresponding. So we know that K prime L prime has a side length of 18, and that KL has a side length of 12. So we're going to find the ratio of that to know what our scale factor is. And that means we write it as a fraction, image over pre-image. So the image is 18 divided by the pre-image of 12. And if we can reduce that fraction, that reduces down to 3/2. If we divide both by 6. So our scale factor here is 3/2. Every side got longer by 3/2, which is 1.5. And we found the scale factor just by dividing the length of the image divided by the length of the pre-image, aka your new side divided by your old side. Okay, let's work backwards. Oh no, you guys try this. Find the scale factor. So you are given a dilation, and we're first going to determine, is it an enlargement or a reduction? So look at our notation. Remember that the primes mean it is the image of what happened. So we started out at this black triangle ABC, and then our image after the transformation is smaller triangle ABC prime. So is it an enlargement or a reduction? It is a reduction. It got smaller. So the big thing we have to pay attention to is where those tick marks are, so we know which one is the image versus the pre-image. So now let's find that scale factor. So we know we want to do image divided by pre. So I'll find the length of one of the sides of the image. I can just find this AB. That's got a unit of 1. So AB prime is 1. The original AB is 2 units. So our scale factor is 1/2. Every side was reduced by 1/2. And if we check that, this side was 1, 2, 3, 4, and this side was 2. Perfect. Scale factor of 1/2. Now let's talk about a dilation with the coordinates if our center is at the origin. And this is all about if the center is at the origin. We see the notation, what are the vertices of D sub 3 triangle ABC? So that notation means the image of ABC after a dilation centered at the origin with scale factor 3. AKA, it's a whole positive number. It's not a fraction. It's not less than 1. It's greater than 1. The scale factor is 3, which means we are going to enlarge each coordinate by a scale factor of 3, aka all we have to do is multiply by 3. So I'm going to take each one of these coordinates and I'm going to multiply it by 3. So the pre-image point of A is 2, negative 1. The image point is going to be 2 times 3, which is 6, and negative 1 times 3, negative 3. And we're going to do that for each coordinate. So B was originally at negative 1, 2. So B prime, let's multiply by 3, is at negative 3, 6. That means C prime, let's multiply by 3, is going to be at 9, 0. And now you know the coordinates because we knew that the scale factor was 3, so we multiplied those coordinates by 3. And that is dilations.